Well, hey, so, hey guys, or Twitch, everybody that's on here. My name is Eric, also known as Echo Tango 86. You just call me Echo Tango or Eric, whatever. Um, this is my first video. This is the first time I'm on Twitch. I don't have any followers or really anybody that even knows I'm doing this at the moment yet. But hey, if you see this video down the line, maybe on YouTube or wherever, um, hi, thanks, welcome. Um, so, a little bit about who I am. I am a computer engineer. I got my degree from the University of Washington, Tacoma campus, and this is where my passion is. I really love electronics. I love messing around with gadgets and learning why circuits work the way they do and the math behind it and all the science that goes into it. I've always been interested in that kind of realm. So that drew me into the education of computer engineering. I also like programming, making programs run to do crazy cool things. Mathematical algorithms to I don't know, programming simple little games. So you're probably wondering what this channel's about. Well, do you call it a channel on Twitch? I don't know. I'm hoping to get some of you in here and you can help kind of teach me how this whole thing works a little bit. But the main focus here is around electronics. And when I say electronics, I don't mean like, hey, here's the new camera unboxing video, this is how it works, look at it, take a picture. I mean like, hey, this is using a 555 timer, and the reason we're using that is because we want to control the clock cycle that goes through and allows our computer to run at a certain frequency. Here's how we calculate that out. This is how we put the circuit together. This is how we chose the resistor and the capacitor to give us the time frequency. That kind of electronics. So if you've ever been interested in like, hey, how does these capacitors, resistors, transistors all work, and why do we use them, and how did you come up with this schematic, this is going to be a good channel for you. Everything from the, newbie, someone who just started learning, hey, there's this thing called soldering, and there was this cool soldering kit, and I made a little robot bug thing that runs around the carpet. Don't know how it does it, but I did it, and that's cool. To people who are in the career field that have been here for years and done all kinds of amazing things that know things that I still can't even wrap my mind around. This channel is for everybody. And I'd like it to be that way because it would be a really cool resource place for everyone to kind of come together and share their passions, share their hobby, and learn and grow and become better engineers or potential future engineers if you're looking at going to school sometime soon, getting your degree. I'd love to have electrical engineers, computer programmers, everything. As you can see, I am in a garage. This is where I have my lab set up. In fact, get the camera right, that's a 3D printer right there. The Anycubic, it's like a 15-inch by 15-inch build platform. Pretty big, like 300 centimeters by 300 centimeters by 300 centimeters, something like that on the metric side. If you're over on the pond. Now, as an engineer, I do like working with that metrics because all my equations and everything are on that kind of system. So, kilometers and kilograms and centimeters, I'm used to that. In fact, it drives my dad nuts because he's an engineer, but he's been working it for a long time, so he's always been converting it over to inches and things for his job because he's on the mechanical side, and everything that's done in manufacturing is done on our, imperial system. So he gets frustrated when I'm coming at him going, I need 13 inches or 13 centimeters by something. That's funny. But yeah, anyways, so I'm in a garage, but I have a primary lab that's kind of set up here for all the work that I do. In fact, I'm going to show you a view that's not my storage behind me, but kind of like what I'm working at. So let me switch that over to the lab view. Get out of the way here. So, this is kind of my lab. I call it a lab, but It's where I can do a lot of my work. I got a nice bench. It's got a lot of space on it. You wouldn't tell because I got a lot of things here, but got a nice soldering station, electronics working, mat here. This is where I got a couple power supplies, got my oscilloscope, and a signal generator for doing different things if I need to test out that. I got a microscope right here. Allows me to do really minuscule type of soldering, and allows me to, kind of do the surface mount stuff and figure out what's wrong if there's like a break in a line on a circuit board to repair with some solder. Yeah, so pretty much everything that you would need to get set up, this lab provides. So I know it's a little weird view and it's kind of wobbly. It's a wireless webcam that I somehow managed to work for this. So let's switch back. Now, another view you're going to get to see is when I'm actually working on the electronics. So right now I am building a clock signal generating circuit that'll be going on an 8-bit computer, which we'll talk a little more about later. But you would be seeing that kind of like, turn this light on, this right here. This is kind of the view you're going to see. So on that soldering station that was up there with the blue mat, you'll get a good live view, here's my finger, hi, of what I'm working on and how I'm soldering it together and doing it on the proto board here. Yeah, that's kind of an idea of some of the things you're going to be looking at when we're doing this. Anyways, so why did I start this channel? Why am I even going about this? I am out here working on all kinds of things. I have a project that I worked on with my dad since he's on the mechanical side of things. We have this robot using a Raspberry Pi 3B Plus and a Raspberry Pi Zero W. And when a kid walks up during Halloween, he will pass that little Raspberry Pi Zero, which has a sensor on it for motion sensing, and that'll send a trigger to the other Pi using port commands, and we'll say, hey, there's a kid here, go ahead and activate. And what it does, it runs along this rail, and there's a ghost attached to it, and it's screaming as it's coming at the kid. So the kid's coming up to get candy, and this flying ghost comes screaming at him, freaking him out. And I laugh. You have to have him work for that candy, right? Anyways, it's things like that I do. I've done a lot of Raspberry Pi projects, stuff with Arduinos, ESP86, which is not where I got the 86 in that screen name up there, but besides the point. Anyways, I've done a lot of things. In fact, because of the whole COVID thing, I ended up having to do a lot of my senior project out here, which is why right there is a super cheap CNC machine that I use to CNC out a PCB and do some surface mount and doing things in KiCad and FlatCam and produce the CNC files and created the circuit board. Yeah, I'd show it to you, but I don't have access to it at the moment. Because I'm already out here doing this and I really enjoy it, I figured, well, you might as well stream it. Someone might stumble across this at one point or another. Maybe they'll see the YouTube channel or get the title and learn a little bit about it and realize, hey, this is stuff I'm interested in, or this is things that I do and I'd love to share my knowledge or whatever. And so why not film it? Why not show it? Why not inspire maybe a younger generation into this world? I was teaching a course to a group of girls. It was called the Girls Who Code, and they were younger, probably like 6 to 17, and I went in there to teach them how to disassemble and reassemble computers, what all the different parts were of it, how it works. And I really got a kick out of that. That was fun, and they were excited about doing it, and we were able to bring some really neat experiences for them on how to learn how to build these computers and what they do, and made it interesting. And so with that being the case, I figured, hey, I'm going to be out here doing this anyways. Maybe I can inspire somebody else who's never seen this before, or have heard of this world, but, never got to interact. Saw a bunch of YouTube videos, but you can only do so much with a YouTube video. Leave a comment. But on streaming, they could get questions answered. Why are you using that capacitor and resistor in that manner? What's that for? What's that do? Is there math behind it? And yeah, some of the math might be a little easy. Other math will require, second order differential equations or Laplace transforms or whatever, which is kind of getting up there in the higher level math. Otherwise, I can try to break it down as easy as possible when I do things. So for this channel, this is kind of the introduction and a little bit of showing you what I'm working with here. I'm actively building an 8-bit computer. Now, I would like to say big thank you to Ben Eater. I hope I pronounced your name right if you do see this. But he built a breadboard computer right here. This is kind of a picture of it. And it essentially is an 8-bit computer, which means that it has 8 bits per register when it can calculate things through the ALU and runs along whatever that does with the microprocessor and works with it. So, and what makes it easy at 8 bits, there's a lot of chips and things you can start using for your logic that can utilize 8 bits. If you start going higher than that, it becomes a lot more that you have to add to it on the bus and everything. But the reason I'm building this is not because it hasn't been done before. It has. The more I learned about this 8-bit breadboard computer, the more I realized that it fell right in line with everything I learned as a computer engineer, starting from my junior year up. And because of that, I realized that, if I can really document this and do the math behind it, do model sim to simulate the circuits and what's happening when you go high and low on certain bits, what the outcome would be, drawing out the circuit schematic, connecting things up, building it, that I can possibly go back to the school and say, hey, we should subsidize our learning with all these theories on actually doing a year-long 8-bit computer build. I don't know if they'll take it. Haven't approached them yet. I still have a ways to go. In fact, I'm getting pretty far in it. Let me bring this up for you. As you can see, I've been building a bit, following Ben's logic there. And it's great. It is really well done. And it is going to be really nice to take those theories that you learn and then apply something to it to make them a little stronger and grasp, what is an instruction register? Why am I only using 4 bits of information from that? What's the other 4 doing? Most significant bit, what's least significant? What does that even mean? There's just so many things that I remember questioning when I was learning it, like, what does any of this mean? How does that work? What is that debounce? What's a debounce on a switch? You debounce the switch. It literally means so it doesn't do that and just hits once. But all those questions, I remember, are answered in here and drawn out, and you see a circuit that fixes and resolves those issues. And so I'm thinking it would be really neat for their junior years to go ahead and build this in corresponding with the class that they're taking. When they're talking about logic design, they're building the clock and maybe start the register and figure out how the bits go through and when it turns on and off, and use the and OR gates and XORs and NANDs and what have you. And so by the time their junior year is done and all the courses they've taken, they've done their labs and things with it, but then they've also done met up twice a week to work on this computer. and put it together, and then eventually we'll have it set up. And then when the computer architecture comes in, they're learning about assembly. They can go in there and program it and do everything they need to do there, which would be really neat. So what I'm going to do here is I'm working on building that computer, and we'll finish it together. But I showed you the circuit before. This is going to be the clock circuit here, and it's going to allow me to adjust using that potentiometer you see there, how fast the frequency of the clock pulse is. That works with it at the most optimal megahertz, and then it's also going to allow me to switch it off from being automatic to individually push a clock sequence for debugging purposes. And what's nice is that since it's all soldered and connected together in this form, is when I go and start putting the computer together, I'm not going to have to worry about loose cables or anything that can give me wrong readings. Because right now, on that breadboard that I showed you there is like 1 or 2 wires that are intermittent on hitting, and so then when I'm like trying to add or subtract, and I'm expecting a value out, one of these LEDs lights up regardless on the output, and it's frustrating to try to diagnose. And you know, when you get each individual block working, it's good, but when you put it all together, it could be bad breadboards, could be cheap wires. It's hard to say. Everything of this came out of my pocket, but if we were to do it at the school level, they'd have some money to where we could actually get high quality breadboards, high quality wire that sticks together there a little better and make it a real nice kit. Anyways, yeah, so this is more of an introduction day than it is a working day. Plus it's really hot. It's in the middle of the summer right now, and this garage just heats up. And so I'll just be sweating out here if I'm working, to be honest with you. But yeah, welcome to my stream. I hope this is something interesting to you. Hit me up on stream chat. I'm sure my email's somewhere in there. You can email me. I don't do social media. You might find me if you look hard enough on LinkedIn, but that's about the only place I have that, and that's just because I only use that for work and for the ability to network. But I don't do social media. I don't do the Snapchat thing or anything. I'll post my videos to YouTube after they're done. You'll have them here for like 16 days on Twitch, and I'll try to get a little more of a normal schedule. My work schedule is going to change here soon, and once that does and I have that kind of set in, I'll know how often I can come down here and stream and chat. But yeah, thanks for taking the time to view this if you're still watching, and I hope you have a great day. Bye now.